Welcome to my class. In our last class, we have already learned about some important properties of square numbers. In this class, we will learn about some important patterns of square numbers. So let's start the class. Now the first pattern of square numbers, what it says is sum of two consecutive triangular numbers is a square number. Now we already have the what is a triangular number. Now this is a triangular number, and how many elements or dots are there? We can see here that there are three dots. So this triangular number represents 3. So this is a natural number, and the next triangular number is, here we have 6 dots or 6 elements, so it is 6. Now what we have to do? Sum of two consecutive triangular numbers. So we have to add these two numbers, and that is 9. And 9 is what? 9 is a square of 3. So sum of these two triangular numbers is a square number. Now the next triangular number is, let's see how much it is. It will be 1 plus 2 3 plus 3 6, then 6 plus 4 it will be 10. So now if we take these two consecutive triangular numbers, then it will be 6 plus 10. So it will be 16, and 16 means it is 4 square. So again it is a square number. Now the next triangular number is, it will be 3, then we will have 4 dots, and then we will have 5 dots. So it will be 3, then 3 plus 3 6, 6 plus 4 10, 10 plus 5 15. So it is 15. So these two consecutive triangular numbers, if we add, then it will be 10 plus 15, so it will be 25. And 25 is what? 25 is square of 5. So summation of any two consecutive triangular numbers is a square number, and this is very interesting pattern of square numbers. So let's move on to the next pattern. The next pattern says that the sum of first n odd natural numbers is n square. So first n odd natural numbers. So odd natural numbers. Say let's start with 1. Then the next odd number will be 3. Then it could be 5, 7, 9, 11, and so on. So let's choose first 3 odd natural numbers. So if we add these 3 numbers, then it will be 1 plus 3 plus 5. So how much it is? It is 9. And that is what? That is square of 3. And square of 3 means here we have chosen 3 numbers, 1, 3 and 5. So altogether there are 3 odd natural numbers. So it will be 3 square. So what is the pattern? Sum of first n odd natural numbers, here n is 3, will be n square. So it is n square or 3 square. Now if we choose first 5 odd natural numbers, then it will be 1 plus 3 plus 5, then 7, and then 9. So how much is the summation? So the summation is 4 plus 5 9, 9 plus 7 16, plus 9 it is 25. And 25 is what? 25 is 5 square. 5 square, how many numbers we have chosen here? Here n is equal to 5. So here it is n square or 5 square. So this is also very interesting pattern of square numbers. Now the next pattern says that there are 2n non-perfect square numbers between two consecutive square numbers n square and n plus 1 square. So two consecutive square numbers we have to choose first. So let's choose first 3. 3 and square numbers is, square of 3 is what? 9. And the next square number is what? So it will be 3 plus 1 square, that means 4 square, so it will be 16. Now between 9 and 16, how many digits or natural numbers are there? 10, 11. So how many? 1 2 3 4 5 6. So between 9 and 16 there are 6 natural numbers, and all of them are non-perfect square number. So if we take the square root of these numbers, they will come in fraction, they will not be integer. So between 9 and 16, 6. And what this pattern says? This pattern says that there will be 2n non-perfect square numbers. So n was what? N was 3 in our case. It is n is equal to 3, and this is n plus 1. And this is 6. So 6 is what? 6 is 2 multiplied by n. So there will be 2n number of non-perfect square numbers between these two perfect square numbers, which are consecutive square numbers. Now if we choose, suppose 16, so if we choose n is equal to 4, so n is equal to 4, if we take now square, then it will be 16. So next natural number will be n plus 1, so it will be 5, and 5 square means 25. Now between 16 and 25, how many numbers are there? So between 16 and 25, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 non-perfect square numbers. So 8 means what? 8 means 2 multiplied by n. And 2 multiplied by n means 2 multiplied by 4. Whereas the 4 was the value of n that we have chosen here. So this proves this pattern. Now the next pattern says that if 1 is added to the product of two consecutive odd natural numbers, it will be equal to the square of the only even natural number between them. So first what we have to choose? We have to choose two consecutive odd natural numbers. Now one natural number, suppose it is 3, and then the next odd natural number will be 5. And then what we have to do? We have to add 1 to the product of these two consecutive odd natural numbers. So first we have to multiply them. So it will be 15, and then with 15 we have to add 1. So it will be 16, and 16 is what? 16 is 4 square. And where this 4 lies? 4 lies between 3 and 5, and 4 is even. So let's repeat this statement. If 1 is added to the product of two consecutive odd natural numbers. Two consecutive odd natural numbers. This is the product, and we have added 1. And that is equal to the square of the only even natural number between them. So 16 is 4 square, and 4 is the only even number between these two consecutive odd numbers or odd natural numbers. Now if we choose, suppose 7 and 9. This is one odd natural number, the next odd natural numbers. Now if we multiply them, so 7 multiplied by 9, it will be 63. And 63 plus 1, it will be 64. 64 is what? It is a perfect square number, and it is square of 8. And 8 lies where? 8 is in between 7 and 9. So 8 is the only even number which lies between 7 and 9, these two consecutive odd natural numbers. Now suppose if we choose 13 and 15. Now what we will do? We will multiply these two consecutive odd natural numbers, and that will give us 150 plus 45, so it will be 195. Then with 195, what we will do? We will add 1. So it will be 196, and 196 is a perfect square, and that is the square of 14. And 14 is what? 14 is the only even number which lies between these two consecutive odd natural number 13 and 15. So this is what this pattern is all about. Now we will see the next pattern of square numbers, and that says that if 1 is added to the product of two consecutive even natural numbers, then that will be equal to the square of the only odd natural number between them. So it is just the opposite to the previous pattern. So initially, or in the previous pattern, we took two consecutive odd natural numbers, and then we multiplied them, and then we added 1 with that, and then we saw that this is the square of the only even number between them. And this time we will choose first the two consecutive even natural numbers. So let's choose 4 and 6. Then what we will do? We will multiply them. So it will be 24. Then we will add 1 to that. So it will be what? It will be 25. And 25 is what? 25 is square of 5. And 5 is what? 5 is the only odd natural number which lies in between 4 and 6. These two consecutive even natural numbers. Now let's choose 8 and 10, these two consecutive even natural numbers. So now when we will multiply them, it will be 80, and 80 plus 1, it will be 81, and 81 is what? It is square of 9, and 9 is the only odd natural number which lies between these two consecutive even natural numbers. Now let's choose 12 and 14. So when we will multiply 12 and 14, that will give us 168, and when we will add 1 to 168, then that will be 169, and 169 is what? 169 is square of 13, and 13 is what? 13 is the only odd natural number which lies between 12 and 14, these two consecutive even natural numbers. Now we will see the next pattern, and it says the square of any odd natural number other than 1 can be expressed as the sum of two consecutive natural numbers. So what we will do, first we will choose any odd natural number. Let's choose 7, and then what? We will take the square of 7, so it will be 49, and other than 1 it is written. So square of any odd natural number other than 1 can be expressed as sum of two consecutive natural numbers. So 49 can be expressed as 24 plus 25. So these two, 24 and 25, these two are consecutive two natural numbers. One of them, since they are two consecutive natural numbers, so definitely one of them will be even natural number and the other one will be odd natural number. Now let's choose 11. So 11, if we take square, then it will be 121, and 121 can be written as 60 plus 61. So again, these are this is the summation of two consecutive natural numbers. Now suppose if I choose 21, and if I take square of 21, then it will be 441. So 441 can be further written as 220 plus 221. So that will give us 441. Again, this is a summation of two consecutive natural numbers. So this is also very interesting. Now we will move on to the next pattern. Now we will notice something interesting here also. And it says the squares of natural numbers having all digits 1 follow the following pattern. So we have not started here with 1. So if suppose we consider 1 also, then that will be 1. But if we exclude that and if we start with 11, then 11 square is 121, then 111, triple 1, and if we take the square, then it is 12321. And if we keep on increasing one digit, and that itself is 1, and if we take the square, then it will be like this. And what is the pattern? There will be always odd number of digits in the square, and the middle digit will increase by 1, and the other digits on both the sides with respect to that middle digit, or the digit at the middle point, will be symmetrical, or we can say it will be mirror image. One side will be the mirror image of the other side, and this pattern is called palindrome. And the third point what we have noticed here is that if we sum all these digits, then that will be a perfect square. So 1 plus 2 plus 1, that will be 4. So 4 means 2 square. 1 plus 2 plus 3, it is 6. Then 6 plus 2, 8. Then plus 1, it will be 9. So it will be 3 square. Then 1 plus 2 plus 3, it is 6. 6 plus 4, 10. 10 plus 3, 13. 15. Then 16. So 16 means it will be 4 square. So always when we will add all these digits of that square, again the summation itself will be again a perfect square number. So this is the third point about this pattern. Now the next pattern is also very interesting, and the left hand side is same as before, same as the pattern number 7, and here 1 2 1, again the definitely square of those numbers will be same, but the pattern is here different. And what it is, that the pattern is the square of 11, we know that is 1 2 1, and when with 1 2 1, if we multiply the summation of these three digits, say 1 plus 2 plus 1, it will be what? It will be 2 plus 3 plus 4, 1, 2, 1, then 4, then it will be 484. And this 484 will be square of 22. And 22 is what? 22 is, we can further say that it is 2 multiplied by 11 and then square of that. Similarly, when we will come to this relationship, then again the value that we are obtaining here as the square of this 111, with that 1 2 3 2 1, with that if we multiply the summation of these 5 digits, then it will be, so summation will be how much? It will be 3 plus 3 6 plus 2 8 plus 1 9, and 1 2 3 2 1 will be multiplied by 9, and if we do that, then it will be 1 1 0 8 8 9. The result of this multiplication will be this. And if we, this is also a perfect square, and if we take the square, then it will be the square of 333. And 333 is what? 333 is 3 multiplied by 111 and then square of that. And then next, if we come to the next value, which 1 2 3 4, then 3 2 1, so this is also a perfect square. 1 2 3, then 4, then 3 2 1, and with that what we will do, again the same thing. So we will add all the digits. So 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1. And what is the summation of all these digits? It is 3 plus 3 6 plus 4 10 13 15 16. So this number, when it will be multiplied by 16, then the result of multiplication will be 197, then it will be 49136, and this value is also, this is again a perfect square, and this is square of 4444, then square of that. So I hope you have already identified the pattern. Here it is square of 11, and with 121, the square value of 11, with that we have multiplied the summation of these 3 digits, and whatever value we have obtained here, that is square of 22, and 22 means 2 multiplied by 11, and 2 multiplied by 11, what is the relationship with this 11? Here it is 11, so 11 is being repeated here, and here we can say here we have 2 digits, so this is 2, or we from here also we can say that the middle digit or the digit at the midpoint is also 2, so this will be repeated, it will be written here in this pattern. Now if we come to the next value, this is 3 multiplied by 111, so 111 will be coming from here, and since we have 3 digits here, so this from this there, that concept also we can say that this will be 3, or here we have the middle digits as 3, so from there also we can say this will be 3, and then with our closed eyes we can say that when we are doing we are taking the square of this 4 ones, then it will be definitely, it will be 4 4 4 4, so it will be 4 multiplied by 111, then square of that. Sorry, this will not be equal, this cannot be equal, so this is actually, from this relationship we can form the other, this relationship or pattern. So the pattern is, if we are taking 1 1 and if we are taking the square of that, then with that result, if we add all the digits, the summation of all the digits, then that result of multiplication again will be a perfect square, and that will be 2 multiplied by 1 1 and square of that. So similarly, suppose if we have here 1 2 3 4 5 6 7 ones, and if we take square of that, so whatever is the value, finally with that square, if we multiply the summation of all those digits, what is the value here? If we add all these digits and if we multiply that result of summation with this, then that will be again a perfect square, and that square will be, here we have 7 digits, so it will be finally 7 multiplied by 7 ones and then square of that. So this is how, if we know this pattern, if we know this rule, then easily we can find the square value of this pattern. Now here we have 1 2 3 4 5 6 7 8 9, so this square value is a huge number, and with that, with this result or with this square value, now if we multiply the summation of all these digits, then finally it will be, yes, you have already we have guessed that what it will be. It will be 9 multiplied by 9 ones and then square of that. So this is what this pattern says. Now next pattern is, after observing this pattern, what we have seen here, that it is 7 square, which is 49. Then we are just taking a digit which is less than 7, so it is 67. And when we are doing the square, or we are taking the square of 67, then for with 49, what we are doing with 49, before 9 we are adding 8, 7 plus 1, and then it will be 2 fours. Okay, now when we will be adding one more 6 with that number on the left, then it will become 667. And when we will take the square of 667, then what will be the square value? Again the 9 will remain 9 at units place, and this 8 which it came when we took the square of 67 at tens place, then that 8 will be increased by 1, so another 8 will come at hundreds place, and there will be one more 4. So here, so from 2 fours we will have now 3 fours. From 8 we will now have 2 8, and then there will always remain 1 9, and that will be always at units place or ones place. Now if we increase 1 6 to that number, and that will come at thousands place, so it will become 6667. And now if we take the square value, so it will be what? At units place it will be again 9. Now initially, or in the previous number we had in that square, we had 2 8s, so here we will have 3 8. Now initially, or in the previous square number, we had 3 4s, so now it will have, or we will have 4 4s, and this way we will continue, provided the number should have 7 in the units place. And if we, when we will increase the number of digits, definitely at tens place, hundreds place, or thousands place, it will be always 6. So if it is, then the square number also will follow this pattern, where in the units place it will always have 9, and then the 8 will be increased by 1 as we will increase the number by 6, and 4 also will be increased by 1 as we will move on, or we will increase the number by 6. So this was about the important patterns of square numbers. In the next class we will learn something new. Till then, bye bye.